Hey, grade 11s. Let's do the exam style questions on page, I don't remember, 111, 112, 112, 113. I don't remember. And then we'll do a review page that puts everything you need to know on one page for you. Let's get down to it. So here we are on page 112. So we have a function. There we go. It's graphed for us over here. There we go. I want to know the points A and B. So the first thing we do, if I want to know the points A and B, I can see those are the roots. So A and B are the roots. So what I do, I've got f of x equals 2x squared minus 12x. So I can rewrite that, of course, as y equals 2x squared minus 12x. The best thing to find roots is either factoring or the quadratic formula. I don't like this for the quadratic formula because it's so easy to factor. Y equals 2x, x minus 6. So I know that the roots are when y equals 0. So either 2x has to equal 0 or x minus 6 has to equal 0. So x has to be 0 or 6. So A equals 0. And some of you will say, well, obviously it goes through the origin, Mr. Myers, so I only have to write 0 right away. No, you still have to do the algebra, because what if it was like 0.1 or something? And B equals 6. Now, the axis of symmetry. We know that the axis of symmetry is the line that goes right through the middle of a parabola. And we know that it has to be halfway between those two. So that was A. So for B, we know that P plus Q divided by 2 equals the axis. Well, that's 0 plus 6 over 2 equals 6 over 2, which equals 3. So this is x equals 3. And then find the coordinates of C. Well, I already know that C is x. Is 3 comma y. Because I know that the vertex goes on the axis of symmetry. So there's an x, there's a y. What do I have right there? X, x, y. So all I do is fill it in. Y equals 2 times 3 squared minus 12 times 3, which is 2 times 9 minus 36, which is 18 minus 36, which is negative 18. Y equals negative 18. There's a y. So it's 3 negative 18 to answer C. I'll leave that there for a sec. And then now let's get down to it. This is a bear of a question. First of all, you have to know what that means. You know what that means because that means we are taking, if you think about it, the f of the g of x. That means we have to put g of x into that function, which means that x, the f of the g of x equals the f of the g of x, which equals the f of x squared, but g of x is x minus 2. So it's x minus 2 squared plus 3, because the g of x is what's got to go in for x. So we do this work. X minus 2 squared plus 3 equals x squared minus 4x plus 4 plus 3, which equals x squared minus 4x plus 7. That is the first function. Then I want to write down the coordinates of this graph. All right, so I have to find, so that was A. So B, I want the vertex of this graph. So how do I find the vertex from standard form? Well, the easiest thing to do is to use the completing the square. So right now I have y equals x squared minus 4x plus 7. I'm going to move that over there. Y minus 7 equals x squared minus 4x. Then I complete the square. Divide by 2, square. So I am adding 4. So I add 4. Y minus 3 equals x minus 2 squared y equals x minus 2 squared plus 3. Now, some of you will notice, Myers, you just did a ton of work. You already had it right there. That's vertex form. So, the vertex equals 2, 3. Now, there's a third function here. I translate this graph 5 units in the positive direction on x. So I have to add 5 to x and 2 units negative y minus 1. So my vertex of function h equals 7, 2. Now I got to write a new function. So this is C. I have a vertex. Y equals a x minus 7 squared plus 2. That's my new function. Right? Now all I got to do is take that and put it into general form. Now, do I need to worry about A? Did I have an A here? If I don't have an A here, am I going to have an A here? No, because I just took the graph and I moved it 5 that way and down 2. So my A is still going to be just 1, so I don't need to worry about it. So all I have is y equals x minus 7 squared plus 2, which is x squared minus 14x plus 49 plus 2, which is x squared minus 14x plus 51. That is C. And then D, I want the y-intercept there. The y-intercept there is when x is 0. So that's 0 minus 0 plus 51. So it's 51. And I'm done. Now, I know that wasn't a lot of work. It seems like a pretty short video to do, but it's because I wanted to fill this in, because you guys are going to have a quiz soon on everything we've done in quadratics. So I want you to have this page right here that has it all on one page. So here we go, standard form. That's ax squared plus bx plus c equals 0. We know, just by looking at that, we know two things. One, we know the y-intercept equals c, because x, the y-intercept, is 0, comma y. So that 0 would go in for x's. So we know that. That then gives us 0, comma c to sub back in if we need to later. The other thing we know, a. If a is positive, it's that type of parabola. If a is negative, it's that type of parabola. And we know that from the vertex, if we move that way, x, we go up a x squared, or we go down a x squared. We know that. What can we do from here? One, we can factor or quad formula for the roots, which are the x-intercepts. We could complete the square, and that will get us the vertex. Or we could use vertex x equals negative b over 2a, and then sub back in for vertex y. That's everything you can do with standard form. When it's in vertex form, which is y equals a x minus p squared plus h. What do we know? One, we know a still works. The next thing we know, the vertex equals the opposite of p and the regular h. What can we do with vertex form? We can graph by plotting the vertex and counting for the points using the a value. Something's going on in my house. I just need to pause for a sec. Sorry, we're back. And the other thing we can do with this is we can get a y-intercept by subbing in x equals 0. And lastly, when it's in factored form, y equals a x minus p x minus q. What do we know? A still works. 2, we know that the roots, which are the x-intercepts, are the opposites of P and Q. What can we do? we can find the axis of symmetry by P plus Q divided by 2. And of course, the axis of symmetry is the vertex x value. And then, as always, you can sub Vx back in to get Vy. And then you're done. You've got everything you need to solve. Now, please remember, you can always use the quadratic formula, but you should be able to use all three. Okay? And that's it. I'm going to pause just to make sure I've covered everything I want to for your upcoming quiz. If there's something I need to add, I'll come back and add it. If not, this will probably be the end of the video. Just give me a sec. I did remember something. There's some space down here. Let's remember. A parabola looks like this, or like this, or whatever. In math, parabolas cover all the x values. Their domain is x is a set of real numbers, which you saw in grade 10. Because this is spreading out this way, eventually in math, every single x will be covered. But, oh wait, let's do something cool for the kids. IRL parabolas usually have restrictions. Like you can't have negative time or something like that. So you wouldn't go below 0. The other thing I want to mention to you is this point right here is a minimum, which means all all range values are greater than that. So if this was -4, this range y would be greater than or equal to -4 for that one. I'll change colors. This one, say that's 6, that's a maximum, which means all the range values are less than that, which means y would be less than or equal to +6. And now that's everything. All right, you guys, keep an eye on your classroom stream. There's going to be a quiz coming up on it pretty soon. Tomorrow I will have my usual live meets. But I think I have an appointment tomorrow, so I might not be doing the afternoon meeting. If I do, I will put it in the stream. I might only be doing the morning meeting. Friday you have a day off for Pro D. Monday you have a day off for Victoria Day. Tuesday I'll have a live meet to ask any questions, answer any questions as always. Your next new video is 1 week from today. Use the time, do something fun that you're allowed to do. Have a good weekend.